Okay, in this video, we are going to talk about power transmission. So the idea is we have a power plant produces electricity, and somehow we need to transmit it to our houses. Okay, so if you look at your notes, page 4.3, there's a diagram. Say, what we can do is let's assume the electric, the power plant generates electricity at 20 kilowatts. Okay, and the voltage is 20 kilowatt, and if the current, I just make those numbers up. If the current say is say 100, no, no, let's make it less. Say the current is 2 amps. Okay, now, and somehow this power has to transmit it to houses. Okay, but before we do the transmission, I would like to talk about the power loss. So, let's talk about it. Okay, so as a common sense, we all know that the power is transmitted to the houses through wires. Okay, and wire has resistance, and when it has resistance, so it means it resists the current, and somehow power is going to be lost. Power is going to lost to the resistance to heat the resistance up. That's the reality. We don't want it, but it happens. So, yep, this is an equation I want you to remember. Okay. The power lost will be equals to I square R. Okay. So, yep, we just treat the resistance, the wire as a resistance, okay, as a resistor. The power used by that resistor is the power that's lost when it's transmitting. So if you look at this equation, the power lost, okay, the power lost, do it like this, okay. Now, we cannot change the resistance. If you look at those wires, okay, the copper wires, what we do is we try to make it less resistance as possible, but still there's a resistance and we cannot change the resistors. So if the resistance is constant, okay, so what we can say the relationship between power lost and the current will be like this. Okay, so as the current is higher, there will be more power lost, because the power lost really depends on the current, because resistance is fixed. So yeah, so in order to reduce, okay, the power loss, what we invented was we use transformers. Okay, so here is the important part. So when the electricity came out of the power plant, we use transformers to step the voltage up. Say, let me do an example. Say if refer to the diagram. Okay. Say if I use transformers, so to step. So I use a step up transformer to step just to make the voltage to say 500 kilowatts. We can use the equation to figure out the current after stepping it up. Yep. So if you use the equation with transformer V1 V2 equals to N2 on N1, do sorry, no, not N, made a mistake. Okay. I2 on I1. Okay. So what we can do is I need to find I2, so let's put all the number in. So I have 20,000 divided by 500,000. So if you type this in your calculator, the current would decrease. Okay. Now, okay. Just be careful. Okay. Just be careful with this. Okay. The reason we use transformers to step up the voltage is because we need a decrease in current. Thus, the power lost would decrease. But the power inverse, remember P equals to VI, stays the same. It's always the same. The power before the transformer and the power after the transformer is the same. So the transformer doesn't lose any electrical energy. It just changes the voltage and the current. So after we step it up, we draw wires to it. We draw wires to it. This is known as the high voltage transmission line. Those great, yeah. So I show you a picture. You see it all around, but sorry. So if you go to Google power lines, okay, yeah, those ones. You see those great big towers with high voltage power lines. Normally there won't be houses under it because the voltage is really high on the top, but I mean, however, the voltage is high, but the current is very low. Okay? That's why we want it. Okay? So then assume the wire, say maybe a 10 km wire or 100 km wire. Assume the resistance of the wire during the high voltage is say 10 ohms. We can actually calculate the power loss. And the power loss will be I squared on R, so 0.08 times 10. Type it in your calculator. You get 6.4 watts power lost. Okay, so if you do your math, before was the power equals to Vi, which is 20,000 times 2 is going to be 40,000 watts. Okay. In here, the power is going to be the same. You can do the 40,000 with 10. Okay. However, at the end, because of the resistance in the wire, the power will be this much, take away 6.4. Okay. It's going to be 399 something. There will be less power loss. 399, sorry, 3.6 was. There will be less power loss. So what we do again, as you can see, we don't wire your house directly to the high voltage power transmission line. Okay. So what we do is then we step it up. Step it down. So we step it down to maybe around. I just make those numbers up. So we step the voltage to say 1,000. 1,000 volt. Okay. Then if you do your math again, V1 on V2 equals to I2 on I1. Okay. Using the equation, we can find the current here. Okay. So it's going to be 40 amps. So the value is not accurate. Well, the value is accurate in math in this scenario, but it's not the same as reality. So what's happening is you have 1,000 volts, which is the voltage carried, on the power lines outside your house. Okay. So I just show you a picture. Yeah, things like this. Okay. You see it around your house on the street, which your house get its power from, which is a much lower voltage than those ones, than those great big giant high power transmission lines. Okay. So final step is stepping. In Australia, what we do is we step it down again. Okay, write it here, step down. So step down to what your house need, which is 240 watts standard. Okay. Then you can do the calculation to find out the number. I'm not going to do that, but if I do that, the current will be higher than expected because I made up those values. So the idea is the idea is try to just show you how does it go. So step one, what we do is when electricity is produced from the power plant is stepped up, then travels long distance. When it's close to your street, we step it down for safety reasons. Then it's stepped down to 240 volts again. So we can use our electrical devices in our houses. Okay. So this is the process of power transmission. It all depends on transformers. And if you be aware, transformers only works with AC current. So that's why we have AC current in our house.